Good morning, everyone. Today we will do chemical properties of acid. Now, physical properties of acid and their preparation already done in earlier video. Okay. Now, in this one, in case of chemical properties, generally acid react with other substance. Either it's a element, either it's a compound. So that is basically chemical properties. Now, in this first one is reaction with active metals. Now reaction with active metals means they have already done activity series, or you can say reactivity series. Okay, that same, it's a Kedarnath ka mali alu zara feeke se pakata hai, that you have to learn also. Okay, now in that activity series, those who placed above hydrogen, generally they are active metals. Okay, now in this one, just see skeletal equation. Active metal react with dilute acid. Okay, keep it in mind, dilute acid, not concentrated. Now when both react, it gives salt plus hydrogen gases evolved. So you can take any example in this one. For example, when sodium, it's active metal, react with dilute HCl, it gives salt, it's NaCl, and hydrogen gases evolved. That one is this arrow. Okay, it is a symbol for evolution of gas. Now in this one, second thing is, okay, it's not necessary to dilute HCl, you can take other acid also. Now just see in this one, potassium react with dilute H2SO4. Okay, now in this, that K combined with SO4, so it forms potassium sulfate, is a K2SO4 plus hydrogen gases evolved. Now in this, how to identify that hydrogen gases evolved? So in this one, simple. If you will bring burning matchstick near the mouth of test tube, it will produce pop sound. Okay, we'll perform all these things, I'll show you in lab also. Okay, now next one is this reaction. This one is very important. When zinc react with HCl, it gives ZnCl2 plus hydrogen. So you can give any example when active metal react with dilute acid. Okay, now keep it in mind one more thing, that in this one, generally dilute HNO3. Okay, generally will not use HNO3 in acid. Why? Because HNO3 is a very strong oxidizing agent, and instead of forming hydrogen, it form water. Okay, so whenever we use HNO3, so it is very diluted, and generally magnesium and manganese, it's a manganese. Okay, symbol of manganese is, it's a Mn, capital M, small n. Okay, can produce hydrogen with very dilute acid, and that one is 1% acid. Okay, so maybe question is ki why HNO3 is not used, okay, for production of hydrogen? Because it is very strong oxidizing agent. Okay, this one is your first reaction or chemical property. Now second one, again important. Now in this one, second is reaction with bases. Now acid react with base, and this reaction is also known as neutralization reaction. Okay, why neutralization reaction? Now just see, acid react with base, it gives salt and water, means base neutralize acid, or either you can say vice versa. Okay, now in this one, it forms salt plus water. So you can take any example. Acid, it's HCl. Now base. Okay, what is base? Okay, this one is our next topic, but still for your knowledge I'll explain. Bases are metallic oxides and hydroxides. You know metal, you know oxygen. When metallic oxides or either hydroxides are there, they are bases in nature. For example, sodium, and along with OH, it's a hydroxide. So NaOH. Copper, CuO, it's a copper oxide. Okay, now MgOH ka whole twice, it's a magnesium hydroxide. So they are bases in nature. So when acid react with base, it gives salt and water. Now just see, HCl, NaOH, acid plus base, it gives NaCl plus H2O. It's a type of double displacement reaction also. Now same, you can take another example. H2SO4 along with NaOH, you can take KOH, you can take calcium hydroxide. Okay, your wish. Now it forms sodium sulfate plus H2SO4. Now just see, check, this reaction is not balanced. Balancing is your work also. You have to balance it because you know how to balance. Now sodium is 2 here, here also 2, to multiply this with 2. Now after this you have to see another element, that one is sulfur. So sulfur is 1, here is also 1. Now after that oxygen is 4, then 2, 6, here it is 4, but here this one is, now check, it's a 4 plus 5, and here it's a 4 and 2, this one is 6. Now here you have to multiply this. Now again check, after that check hydrogen. Now hydrogen, here it's a 4 and here is also 4, so it means your reaction is balanced. Now next one is, and again this one is important reaction, that one is reaction with, it's a reaction with carbonates, any carbonate, either it's a sodium, potassium, either calcium, carbonates or bicarbonates. Okay, either bicarbonates or to bicarbonate you can say it's a hydrogen carbonate also. Okay, now in this case whenever, okay, now whenever either it's a carbonate or bicarbonate react with acid, okay, now it always gives salt plus H2O plus CO2 gases evolved. Okay, water and carbon dioxide gases evolved. You can take any example. Now suppose sodium carbonate. Now just see, it's a sodium carbonate, Na2CO3, when react with HCl, simple reaction, then it gives what? NaCl, it's a salt, NaCl plus water, it's a H2O plus CO2 gases evolved. So either it's a carbonate or bicarbonate. Okay, same, salt plus water plus CO2 gases evolved. Now in this one, how to identify CO2 gases evolved? When you pass this CO2 through lime water, okay, you know lime water, it's a calcium hydroxide, it's also known as lime water. When you pass CO2 through lime water, it turns lime water milky. Okay, now you can take another example also. This one is, suppose, balancing. Now you have to balance, this one is your work, just check either it's a balance or not balance, otherwise you have to balance it. Okay, now just see in this one, okay, this one is sodium hydrogen carbonate. Now when react with acetic acid, this one is also acid, it's an acetic acid, then it gives what? Salt is CS3COONA, CS3COONA plus H2O plus CO2 gases evolved. Name is, it's a sodium, this reaction is very important, then sodium ethanoate, this one is sodium ethanoate. Okay, now this one is either carbonate or bicarbonate react, it gives salt plus H2O plus CO2. Again balancing is your work, you have to balance it and show it to me also. Okay, now thank you.